lesson number 5 looks at solving quadratic equations using factoring. So all of the stuff that we've seen up to this point has just been a quadratic expression. The x squared plus 5x plus 6, we factored the expression. Now we make it into an equation, so we let it equal something and we solve for x. So what we're going to look at first is something called the zero product law. In the statement x minus 3 equals 0, this is true only if x is equal to what? What minus 3 equals 0? 3. If I have the statement x plus 1 equals 0, that is true if the value of x is equal to negative 1. If I multiply these together, the statement becomes true if the value of x equals 3 or negative 1. Because if x equals 3, this is going to become 0. 0 times this, which would be 4, is still 0. So it doesn't even really matter what the value of this is. This was 0, whole thing's 0. If x is equal to negative 1, this becomes 0 multiplied by whatever gives me a 0. So if I look at this statement, x times x plus 1, this is true when? Well, I have the two parts, x and x plus 1. Let them both equal to 0. So if x is equal to 0, this is going to become a 0 times whatever, I'm going to get 0. X plus 1. Well, if x is equal to negative 1, I get a 0 inside the brackets multiplied by whatever that value of x is, I get a 0 again. So this statement becomes true if x equals 0 or if x equals negative 1. That's the zero product law. The zero product law basically states if the product of multiple factors is equal to 0, factor number 1, factor number 2, factor number 3, factor number 4, if this equals 0, it means that at least one of these factors has to equal 0. So whatever I'm substituting in has to make this one 0, or this one, or this one, or this one. So for example, if a times b is equal to 0, it means that either a has to be equal to 0, or b has to be equal to 0. So if we look at the following, 8x equals 0. What does x equal? X would equal 0. 8 times 0 would equal 0. In b, 8 times x plus 2 times x minus 7 equals 0. The zero product law says if this is equal to 0, whole thing is done, or if this is equal to 0. So when is x plus 2 equal to 0? When x equals negative 2. When is x minus 7 equal to 0? When x is equal to 7. So in C, I have 3 factors because I'm looking for the variables. Either one of these factors equals 0, the whole thing equals 0. There's x is equal to 0. X plus 2 is equal to 0, which means x would be equal to a negative 2. And x minus 7 equals 0, which then mean that x would equal 7. So if x equals 0, or negative 2, or 7, that statement would become true. In the last one, 2x plus 1 equals 0. If I go to solve for x, move the 1 over, it will become negative, and then I divide by 2. Take the other factor, 3x minus 2, let 8 equal 0, add 2 to each side this time, and then divide by 3. So if x equals negative 1/2, it'll make this factor equal to 0. When multiplied by that, will equal 0. If x equals 2/3, when I put it in here, I'm going to get 0, which multiplied by that will give me 0. Part E says, why is it acceptable to divide by 8 in first A and B? Well, because if I divide by a constant on each side, I get an equivalent equation. Dividing by 8 does not actually change the value of the equation. So it does not change the value. So it does not change the value of the statement or of the equation. Okay? The reason why I can't divide by x in part C is because I don't know what x is. What if x happened to be 0? I can't divide by 0. So I have to take that into consideration. So I can't divide by 0, or sorry, I can't divide by x because if x equals 0, I cannot divide by 0. So the statement would become invalid. So it has to be able, if I'm dividing both sides by something, I have to be able to do it in every situation. Because I don't know what x is, I cannot for certain divide by x on both sides. So all of the above equations are polynomial equations in which one side of the polynomial expression and the other side equals 0. So the solution to the polynomial equation is given by stating the values of the variable which make the left and the right side equal to each other. We say that these values satisfy the equation. They make the equation true. We use the zero product law to solve equations of this type. So what we are going to do is we are going to combine the zero product law with factoring to solve quadratics. Consider the equation x squared minus 2x minus 3 equals 0. If I factor this, I get x minus 3 times x plus 1 is equal to 0. Which means if x is equal to 3, this side's going to equal 0. Which means it equals the other side. If x equals negative 1, this will equal 0, which means the left side again equals 0, which makes the statement true. So we can say that the equation is satisfied by both the value of 3 and negative 1, which we can write together. We don't have to write x equals 3, x equals negative 1. I can write x equals negative 1, comma 3. We can get picky and say we want them in numerical order. If you don't put them in numerical order, it's not the end of the day. It's just nicer that way. So if I have the equation x squared minus 9x plus 20. If I go to factor this, because trying to figure out the values of x when it's like this is a lot harder. But if I have these two terms, it might become a lot easier to factor out. So two numbers that multiply to 20 and add to negative 9 would be negative 5 and 4. What that means is x minus 5 could equal 0, or x minus 4 could equal 0. Well, when does x minus 5 equal 0? When x is equal to 5. When does x minus 4 equal 0? When x equals 4. So I can say that the solutions to this statement are x is equal to 5, or x is equal to 4, or I could put them together and get 4 and 5. So I'm going to work through the first example with you and then get you guys to work through the next 3 before you continue on and do the same thing with class example number 3. So if we look at class example number 2, I want to factor this. It's got two terms. I check to see if it's a difference of squares, and it is. So if I go to factor this, I get an x plus 9 and an x minus 9 is equal to 0. So now I can split this up. I have x plus 9 could be equal to 0, or x minus 9 could be equal to 0. Well, x plus 9 equals 0 when x is equal to negative 9. X minus 9 equals 0 when x equals positive 9. So I write for my answer x equals negative 9 or positive 9, or this one I can actually put together and say x could equal a positive 9 or a negative 9. So you're going to do the same thing with the next couple of questions. You're going to factor them and then solve them. When you're done, you can press play and look through the solutions that I worked through. So B, again, is another difference of squares. 2x plus 3 and 2x minus 3. So if 2x plus 3 equals 0 and 2x minus 3 equals 0, the whole thing would equal 0. So I solve for x in this first equation, means that I would move the 3 over and it would become negative, and then I would divide by 2. In the second equation, I would move the 3 over and it would become positive, and then I would divide by 2. So I have a positive 3 halves and a negative 3 halves, so I can put it together and write it as positive or negative 3 halves. When I look at C, I should hopefully recognize this is not a difference of squares the way that it is written, because I cannot square root 10 or 90 or this x. So I look first of all to see, can I factor out a GCF? Well, I can divide both terms by 90 and both terms by x, not 90, 10. So I get 10x, factor out a 10x, and I'm left with x minus 9. So my two terms are that 10x equals 0 and x minus 9 equals 0. So x minus 9 will equal 0 when x equals 9. And what times 10 equals 0? 0. So I get that x could equal 0 or 9. If I look at D, again, it's not a difference of squares, but I do have a common factor I can take out. I can factor out a 10, left with x squared minus 9. That is a difference of squares. So I get an x plus 3, an x minus 3. The 10 I don't have to worry about. The plus and the minus 3, x plus 3 equals 0, so I get a negative 3. X minus 3 equals 0, and I get a positive 3. So x equals positive and negative 3. So for class example number 3, we now have quadratics that we're solving, or 3 terms. So if we look at 3a, we can solve this through decomposition, or we could solve this by sight because of this 3x squared. The only way I can get 3x squared is a 3x and x. Then to get my 10, I have combinations of 10 and 1 and 5 and 2, but I need to get this 13. So the 5 and 2, the 5, I think 15, and there's my 13. So if I put a 5 here and a 2 there, I get 15 and 2. The difference of that is going to be a 13. To get my negative 13, negative 5, positive 2. So if I let 3x plus 2 equal 0 and I solve for x, the 2 would go to the other side and become negative, and then I would divide by 3, and x minus 5 equals 0, I get x equals 5. So my x's could be a negative 2/3 or a positive 5. B looks a little bit different because it doesn't actually equal 0 this time, but we're going to make it equal 0. We're going to bring the 25 to the other side. Now it equals 0. 5, 30, 25, all divisible by 5. So let's factor the 5 out. Now I have a quadratic that should be easier to factor. Two numbers that when I multiply them together, I get a 5. When I add them together, I get a 6. And that would be 5 and 1. Let either one of these terms equal 0 for my zero product law. X would equal negative 5. X plus 1 equals 0. And x would equal negative 1. I don't need to worry about the constant here because I could divide by 5 on each side and that 5 would disappear. I don't need to do that step because I'm more so interested in these two values. So x equals negative 1 and negative 5. What I would like you to do is I would like you to work on questions 1, B and E, 2, B and E, and 3, B and E. Once you've worked on those questions, then you can go on to the next part of the lesson, which has to do with problem solving. When we look at problem solving with quadratics, first thing that we need to do is we need to introduce a variable to represent my unknown value. Let W equal the width. Let H equal the height of the tree. Whatever it may be. You could continue to use X and Y, or you could use letters that might have a little bit more meaning. Form a quadratic equation from the given information, solve it using the methods from this lesson, and then state the solution to the problem. The area of a rectangular sheet of paper is 300 square centimeters. A rectangular sheet of paper. I'm going to draw it out. There's my rectangular sheet of paper, whose area is equal to 300. The length is 5 centimeters more than the width. Form a polynomial equation and solve it to determine the perimeter. So the length is 5 centimeters more than the width. So my unknown, I'm going to let be the width. Measured in centimeters. So if I label that on my diagram, this becomes the width. The length in terms of the width is 5 centimeters more. Becomes W plus 5. How do I find area? Length times width. Area is 300. The length and the width. I get W times W plus 5. If I expand the right-hand side out, I get W squared plus 5W. I'm going to bring the 300 over to this side and make it negative. And now I get 0. Now I'm going to try to factor this. I need two numbers that when I multiply them together, I get a negative 300. And when I add them together, I get a 5. So take a moment if you want and try to see if you can determine this on your own. Things that I do know, well, I know that 10 times 30 is 300. So now I can start to whittle it down. 50 times 20 is 300. If this is a negative 300, I'm looking for differences. Difference is 20. Oh, there's the difference is 5. So I get, to get a positive 5, I need a positive 20 and a negative 15. So the values of W that would make this equal to 0 would be if W equaled negative 20 or if W equaled a positive 15. If we go back to the original question, W represents the width of the rectangle. Which of these numbers does not make sense? I cannot have a negative length. W has to be equal to 50. So the width is equal to 15, which means that the length is 5 centimeters more, means that it is equal to 20. I have not solved the question at this point because I have to determine the perimeter. Perimeter is 2 of the width and 2 of the length. 30 and 40 gives me 70. Now if I look at class example number 5, this is the diagram of the cross-section of a water trough. The sloping sides AD and BC make a 45-degree angle with the horizontal. The length of DC is 36 centimeters. Show that the area of the cross-section is equal to x times 36 minus x square centimeters. So what I can do is I can look at, I've got 3 separate areas. Area number 1, area number 2, and area number 3. Now, this is 45 degrees. This angle here has to be 45 degrees, which means I have an isosceles triangle. And in an isosceles triangle, this measurement here is x units. This has to be x units. And the same thing happens over here. So if I look at my area of 1, it's a triangle. 1/2 base times height. So that's 1/2 x squared. And I have the same thing with my second area. Then I've got this second part right here. What I have here in the middle, this length would be 36 minus these 2 sections, which are 2 x's. So the third area is the length, which is 36 minus 2 x's, times x. So this gives me 36x minus 2x squared. So if I put this all together now, I've got 1/2 x squared plus 1/2 x squared plus 36x minus 2x squareds. 1/2 and 1/2 is 1. Minus 2 leaves me with a negative x squared and a 36x. X is common to both, so if I factor it out, there's my 36 minus x for my final answer. And then the following page, if the area of the cross-section is 260 square centimeters, determine the value of x. So on the previous page, we had shown that the area equals x times 36 minus x, and we let the area equal 260. So I get 36x minus x squared equals 260. In order to solve this, I need this to be equal to 0, so I can use that 0 product law. Because my x squared is negative, I'll move it to the other side of the equation. I'm going to make it positive. Then I'll have to move the 36 over, which would make it a negative, plus 260, and that will equal 0. So I need 2 numbers that multiply to 260, add to negative 36. 260, easiest one is 26 times 10. If this is positive and this is negative, these two signs have to be the same, so they'd have to be both negative. A negative 26 and a negative 10 does equal negative 36. So I get x minus 26 and x minus 10, which means x would equal 26 or x would equal 10. So if I go back to the previous page and that length of that cross section, or that rectangular area, remember it was an x, and then it was a 36 minus 2 x's and another x. So if x equals 10, I will get a 10. And 36 minus 2 of those 10s would be 36 minus 20. I get a 16. And I get another 10. If x equaled 26, I get my 26 here and my 26 there. And then in the middle, when I try to go 36 minus 2 of those 26s, so 36 minus 2 of those 26s, which is 52, I get a negative 16. Remember what I said, can't have a negative length. So this is not possible now, which means x has to be equal to 10. So add 7, 8, 9, and 10 to your questions from before, and that will be it for this lesson.